So I want to look at, we're going to do like a list of like 6 of these. So just so you kind of know what's to plan in your notes. But I want to say, like, let's say n is 50. Let's say p hat. So we take our little slice of the pie and we find out the p hat is 0.6, let's say. And then I want to look at, so that's, those 2 things are going to be fixed. And I want to know, okay, if I have a 90% confidence interval, what is my critical value? Let's do this a little more better. Make it like a table. So let's do percent, and then we'll do z star, and then we'll do the interval, and then we'll do the plus minus, and then we'll do like a little sketch. We'll do 3 of these. I want you to be able to see, like, when one thing changes, how does it impact the other things? So get your calculators out too, because we're gonna you're gonna do the math without doing the entire process. You're basically just gonna type the math. The arms of the mask mandate still exist today.
It was a good change of pace.
It was kind of necessary. Yeah. Looked like someone peed in it.
Mr. Porter once told me during the water fountain and went down to the records, nobody which one was worse. And it was a school.
Compared to what did you say?
An excellent. No.
I don't like. I get to go to the teacher's lounge. I just fill it up with like the bathroom sink, so I'm lucky. But yeah,
That's kind of gross.
These drinking fountains especially have
right. That are like
that
none of them
is
replaced.
that say red, red filter.
All right, so let's say this is I don't know, 85%. Oh yeah, yeah. I didn't know that was a thing. So I want you to find z star based on the percentage. So do you remember what to do there? I want to get out your practice ones. I don't know. Yeah, so that's the inverse norm. In this case, you would do 1.85 divided by 2. And so I get 1.44 basically. I'm going to write this up here too. So it's this. It's the statistic plus or minus z star times. You're not supposed to be here, I don't think.
Oh, I went down there and she was like, don't miss that class.
Oh, really? Did she tell Saturday on the same thing, or she gets to stay?
I don't know.
How would you feel if she told you to come back and said, "Yes, you got to stay"?
I don't know.
All right, so this is your. Did you guys get 1. Let's start. Let's back up. Did you guys get 1.44? Are we good on how to get that? Inverse norm 1.85 divided by 2. All right. Well, so what I'm. Yeah. Okay. Let's find the interval. So then go stat tests. Right. Stat tests. A. 1 prop z interval. So if p is 0.6 for x bar, or for x, you can type in like 0.6 times, because the number of successes would be this times this. So you can put in 0.6 times 50. That'll just calculate it for you. That's 30 for x. So x is 30. You can get to it 2 ways. You can do 0.6 times 50 on your own and then type in 30. Or you can literally just type 0.6 times 50 in that spot. And then N is 50. Confidence level 0.85. And so I get I'm going to round a lot so it'll make it easier to talk about. So I basically get 0.5 to 0.7. Right? So if you were to write that in the this plus or minus this format, what would that be? I don't know if that question makes sense. Yeah. So 0.6, and this is always going to be this. Like this is where you start. That's the middle of your interval. And then we go plus or minus 0.1, so how did Logan get 0.1? Well, that's how far these two things are away from 0.6, right? And then I'm going to sketch, so let's say this is 0, this is 1, and this is 0.5. So I basically got 0.6, or no, 0.5 to 0.7. So I'm like right around in there. That's pretty garbage sketch actually, but hopefully you get what I'm trying to get across. Let me try again. So 0.5 is one endpoint, 0.7 is the other, 0.6 is in the middle. So you get something kind of like that. So what we're saying is we're 85% sure that the true answer is somewhere in there. So that's kind of just a review from yesterday. I haven't really started teaching the new concept yet, but are there any questions on that part there before I move on to something else? Yeah. I mean, you missed an hour lecture. I can't like fix that in 2 minutes, you know. So there's a video you're gonna have to watch. Sorry, man. All right. So what I want to do is change this 85% to, let's say, a 90%. And then I want to like think through what would happen to all the rest of the stuff. So find the Z star. So do inverse norm. And for the area, you put 1.9 divided by 2. Or like 1.90 divided by 2. And so I get 1.64. So then, right there, we can start to talk about, well, okay, what just happened? Think about like when I said if you have to be 100% confident that you guessed my weight between these two numbers, or you die. What are the two numbers you're going to choose? 0 and infinity, right? So the more confidence you need, what happens to your interval? It gets wider and wider. If you want to be 100% confident that you're right, you're going to get the widest interval you can possibly find. So we needed more confidence. So this number went up. Z star. Well, Z star goes up, and you're multiplying by this standard deviation, and you're going to be adding or subtracting a bigger number. If you're adding or subtracting a bigger number, isn't that making your interval wider and wider and wider? So I'm just trying to show you how it fits together. So go ahead and let's find the interval. Stat test. And then A is 1 prop Z int. All I'm changing is the 0.85 to a 0.9. And again, I'm going to kind of round generously just because it makes it a little easier. Let's say this is 0.49 and 0.71. I mean, that's not rounding a ton, but a little. So this starting point is still a 0.6, but now I'm doing plus or minus how much? 0.11, right? And so this got bigger. And then when I go over here and do my little graph, it's going to be really hard to tell. But now I'm a little bit bigger than I was in the one above. So the more confidence you require, now I'm a little more confident my answer is somewhere in there because I have like more wiggle room. The more confidence you require, the bigger your interval gets. You're adding or subtracting a bigger bigger amount from the middle, and then this gets wide. So let's say 99%, which means I got to be almost certain that the answer is in there somewhere. So what's going to happen is, look, before you do it, just don't do it. What's going to happen to Z star? It's going to get bigger. What's going to happen to the interval? Bigger. What'll happen to that 0.6? Nothing. What'll happen to that number? Bigger, and then this will stretch out, right? So let's check and make sure all that happens. So do inverse norm. So the area is 1.99 divided by 2 now. So 2.58. So then whatever the standard deviation is, instead of multiplying by like 1.6, I'm multiplying by 2.6. So it's going to be big. So we're going to be adding or subtracting a bigger number, which is going to stretch everything out and give us more wiggle room to have the correct answer in there somewhere. So do your intervals. So stat, tests, A, just change the 0.99 to a 0.99. So I get like 0.42. Again, I'm rounding a little bit to make it easier to like eyeball. But this just keeps stretching out as we go, right? So this is still 0.6, but now it's plus or minus how much? 0.18. If I go to do my graph, again, it's going to be kind of hard to tell, but just if I exaggerate it a little bit. Get something like that. So the big point here is as confidence percent goes up, interval gets wider. Does that make sense what I'm trying to show you? Question enough? Yeah, it makes sense. No, there's no question. No. Yes. Gotta go here and just fix the water pump. And school lunches. And what's the issue there? You can't just buy a la carte anymore. The whole COVID. Why does COVID make you not able to eat a la carte? Can I move on to the next page or not? So it's not necessarily COVID. Right, which has nothing to do with it. Yeah. Alright, we're gonna change it now. I'm gonna keep P hat the same. And I'm gonna keep the confidence level the same. And what I'm gonna change this time is N. So let's say, so we'll put like N, and then the interval, and then the plus minus, and then like a sketch. So let's say N is 30. Do we have a large enough sample size? Yes. So remember, we need at least 10 successes and at least 10 failures to be able to like proceed. Well, if 50% of the people said yes, 50% of 30 is 15. That's more than 10. And then the other 15 So go ahead and throw that in the stat test A. See what we get. So again, for X bar, you can put like, you could just put, or for X is the number of successes. So you could put 15 there, or you could put like 0.5 times 30. I'll figure that out for you. And I'm leaving the 0.9 as the confidence level. So I get 0.35 to 0.65. So I read that as plus or minus. 0.5 plus or minus 15. Mr. Wally, you with us? Sure. To my untrained eye, it does not appear so, but I must be incorrect. It's probably messing with my mind. Something like that. If I sketch it, that's not perfect. Alright, let's make n bigger. So, if I have more data, would that work? Let's just do it first. Let's say n is 100. Hold on, I want a different color. Go ahead and do that. Take a guess before you do it. What's going to happen to this? Is what I want to know. What's going to happen to that? Will it get wider or narrow? We have more data. We should be able to kind of zero in on it a little better, right? So let's see if that happens. I'm trying to explain it mathematically too, although most people don't like that as well. So now it's 50 out of 100. I hate how if you hit enter, it like takes you off the screen. Yeah, I'm still looking at it, man. So 0.42 to 0.58. Again, I'm rounding a little bit to make it easier. But now it's 0.5 plus or minus 0.08, right? So it got smaller. If I sketch it, we can see that too. So it'd be a little more narrow. I'm not lining those up very well, but you get what I'm trying to show, right? So let me talk through like mathematically why that happens with the formula. Not everyone loves this explanation, but some will. So if I make the number on the bottom bigger, if I take a number and divide it by a bigger number, if I divide the pizza into more parts, what happens to each part? It gets smaller. Well, now I'm adding or subtracting a smaller number, right? So if this number gets bigger, I'm dividing by a bigger number. So take the amount of money you have and divide it among more people. Everybody gets way less, right? So I'm adding or subtracting a smaller number. That number gets smaller, and then my interval gets narrower. So you have more information, so you can kind of zero in on the target a little bit. Let's make it, say 250. If I has 250 people, I'm starting to get where I'm feeling pretty good. But that's a big enough sample size to make some decisions. Let's see what we get. So now it's 125 out of 250, right? So again, I'm rounding a little bit. Let's say 0.45 to 0.55. So now it's 0.5 plus or minus 0.05. And this would be even smaller. So the big point here is as n increases, interval gets smaller. So those two things come up a lot. That's really kind of how they attack this on the multiple choice. So like, here's a situation, I increase n, I'm going to ask more people, what happens to the sentence? Or what happens to the interval? Another thing you can do too, like, if they said what happens to the interval when n goes up, just try it. Like, you don't have to remember it. You can just do exactly what we just did. Just make up a number for n in an interval, and then they're saying what happens to the interval when n gets bigger. Make up a bigger number for n, and see what happens to the interval. You can almost just trial and error your way through it. Question on this. Does that make sense what I'm trying to get across? Okay. Alright, that's alright. Get out a blank sheet of paper. I have plenty up here if you need. So we're gonna make like a cheat sheet. So this thing we're making right now is not gonna be like an actual problem. It's gonna be notes on how to do the actual problem. And you're allowed to use this on your test. Alright, so we do need a title because we're gonna have you end up with quite a few of these different processes. So you're gonna definitely want to label. The AP does want to label too. This is a one prop Z test. No, that's not what it's not a test at all. I'm sorry. It's a one prop Z interval. I'm sorry. You can give them sheet paper if you want. That was wasteful. Complain about it on the board.
I'll bring it up.
So, you guys can do whatever you want with math. Mr. Davis has to stop wasting it. If you want like a little note on how to get to it in your calculator, so it would be stat tests, and then it's A one prop Z int, I think it says. And then I'll be honest, I don't require this. But I really like the circle where you kind of point and say, okay, that's the population. And then we're taking our sample, and we'll know what p hat is. And we define p. So we're going to say p is the true population proportion of, and then you put the context of the problem in there. Every single year, I'll get like 3 tests that literally, like, I'll ask you a problem about, what percent of you think we should have plants in the classroom. And instead of writing plants in the classroom here, people will literally write context. Like, insert the context of the problem into that spot. Don't actually write the word context. Doesn't really do the same thing. Okay, and then we're going to say we want to estimate P at a blank percent confidence level. And that part has to be given to you. Like, I'll have to tell you that part. So that's your intro. Then we do the conditions. Kind of like making sure we're eligible to keep doing the problem. One is you need a random sample. So you're gonna either say SRS stated or assume SRS. So they're either gonna tell you, hey, this is an SRS, and then you would say like SRS stated, or they won't, and you'll be like, oh, they forgot to tell me, so I guess I'm just gonna assume it's okay. Second thing is sample size. We need at least 10 yes and at least 10 no. Or at least 10 successes, at least 10 failures, whichever way you want to say that. And then the third thing is independence. And that is we want n to be less than 10%, less than or equal to 10% of the population size. So if we're doing like Milan High School, your population is like 600 or so. A lot of times it'll just be like of all people, and then it's like the whole world. Yeah. It's kind of like arbitrary. Oh, this one? That's also kind of arbitrary. The more successes and the more failures you have, the better it is. So at some point they just decided like this is good enough. But if you were like an actual statistician, these would change based on whatever you were working with, like how precise you needed to be. But the AP does just that wants to get like kind of general guidelines. The same with the independence. Like when you start not replacing people in your sample, it does change the probabilities a little bit. And this is just an arbitrary decision that like, well, if we're only taking like 10%. Like if you don't put a card back, you know, well, if you only took like 4 cards, it wouldn't really be that big a deal. It changed a little bit, but not a ton. And again, it's just kind of arbitrary. Does that answer your question? Alright, then we get into, then there's the math part. So you got the formula, which is always going to be statistic plus or minus the critical value times the standard deviation of the statistic that you just used. So what's our statistic here? Statistics come from the sample. So what's this? Like, the symbol for sample proportion is p hat plus or minus this is z star, and then our standard deviation is the square root of pq over n. And then you put numbers in those spots. So I'm just gonna put like blank plus or minus blank times the square root of box over blank over box. Like you're just putting in numbers there, so you put a little note to yourself. You put numbers in that spot. But I don't have a problem to work with, so I can't like, demonstrate that. And you can also, if you want to, write down like how do you get z star. So z star is inverse norm 1 point. Let's say like 1 point xx divided by 2. Does that make sense? Like if it's 99%, you put 1.99. If you think of something that you're missing, like let's do this. Get out the ones we did yesterday. Or one of the ones we did yesterday. Actually, let's finish. Then you'll get your you get your answer. And then you make a conclusion. So we're almost done. But then what I want you guys to do is tell me if we should add stuff. I don't know if I'm like 10 years old or mature or what, but every time I draw this, that looks like a flat. Am I about to see that or is that just me? This. Anyway. Alright, then we're gonna say we are blank percent confident. Like we're gonna have to fill that in based on the problem. That P is between blank and blank, and you're just grabbing like the same two numbers and just put in the button. So yeah, get out the one we did yesterday, or one of the ones we did yesterday, look through it, and just like remind me if there's anything else we should write on this. Because you get this on your test. I want you to have a resource for it. So if there's something else we should put on here, but you don't get to like write whatever you want. You get this. But is there something else I threw mine away from yesterday? I think we're good. So there's something else you can think of. Throw it up there. You think we're good? Okay. So keep that, like, you're going to have 11 of these, 11 different processes that we do. Good news for you, well, this is the first year I've ever not made people memorize. So you used to have to memorize 11 of these. If you're going to take the AP test, you kind of got to. But if you're not, I'm not going to make you like these tests. That is a one cross the interval. That's our first inference process. There are the people that have like laminated these, like keep them for college, and that's a little excessive, but it kind of gives you the questions on this anywhere? Anything we should add? Like, does it seem good? Okay. So the next thing, I'm gonna give you a problem. Your job is to do it and show me so that I can make sure you're doing it right. And it's not a grade. If you get it wrong, I'll just say, hey, go fix this. Go back over here. I just want to make sure. It's really easy to like look through the one I put and be like, yeah, I'm fine. But you're missing like a little something. I just want to make sure that's not the case. You might not finish this today, so it might be tomorrow that you give it to me, and that's okay. But let's say. I took an SRS of 60 people that watched the board meeting last night. And 15 of them thought there were crazy people. So the AP doesn't say it like this. Construct and interpret a 95%, let's say, confidence interval. To estimate what proportion of Milan residents agree. So, is 60 people less than 10% of all the Milan residents? Like, how many people are in Milan? 5,000, 7,000? Right? Is 60 less than 10% of like 7,000? Yeah. So that's like why I have to tell you that the population is. I'm not saying who's crazy. I'm not even saying I agree. Just saying it's all. Did you go? I didn't see that part, but someone told me that first.
I was like,
I like how Hanka's mom was like, yeah, I'm a freaking lawyer. So your job is, and this is a check mark. This will be a check mark in the check mark. But you don't have to get it right the first time. Like you can, if you get it wrong, like you can do the whole thing right except for like one part. I'll just circle it and be like, go fix this, bring it back to me, and then I'll do the check. It's not like a high stress situation. I just want to make sure that you're doing it correctly. So you're doing the same process we just did. No, you gotta the same video. Does that make sense what I'm asking?